So you've made it to our bonus lesson on solving compound inequalities. And this is kind of our last lesson for inequalities altogether. And you're going to find that while it may look intimidating at first, these are actually kind of fun to solve. They're basically taking our regular old inequalities and combining two of them together. And it gets to be kind of cool when you see what your answer looks like when it comes time for the number line. So there are two types of inequalities, or compound inequalities, an and or and an or. This first one is going to be an and inequality. Basically what's going to happen is we've got our x, but two things are happening. This 3x minus 8 is greater than or equal to negative 2, but it's less than 10. So it's falling somewhere in between there. There's two different requirements to it. So our rule is we're going to draw a line down through both inequality symbols. Whatever we do to one part, we have to do the same to both of the other parts. So basically now think of it as there are three parts to our inequality. We just have to treat all three of them equally in order to keep everything balanced. So we solve it the same way. Focus on the x. They subtracted 8, so I'm going to add 8. But I'm going to do it on both sides, or all three sides. Here 18 is greater than 3x is greater than or equal to 6. Then we divide. And again, we do the same thing to all of them. And we get 2 is less than or equal to x is less than 6. So when we do our number line, we need to make sure we include both the number 2 and the number 6. So I'm going to start down here. Let's put our 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll put my 1 down here. And then we're going to graph it the same way. At 2, we want to less than or equal to. So here we're going to shade in our circle, closed circle. At 6, we want an open circle because it's just a less than. And then we basically want to shade in the part of the line that qualifies for both of these things. 2 is less than x, so that means x is greater than 2, and x is less than 6. Well, if I look at my number line, numbers that are greater than 2 but less than 6 fall in this range here. So instead of shading one whole side of my number line all the way through the arrow, I'm just shading in between the two circles. Any number that falls inside of here is going to work for both of those situations. So we can do a quick check. Let's take a 4. So we've got 3 times 4 minus 8. 3 times 4 is 12. Minus 8 is 4. Is it true that negative 2 is less than or equal to 4, and is 4 less than 10? That's true. It meets both of those requirements. It's greater than or equal to negative 2 and less than 10. So same thing here. Draw down your line for both of them, and then we're going to solve it. First, we're going to subtract our 21 away. Or if it helps you can think of it as adding a negative 21. Here I get a negative 14 is greater than negative 2x is greater than or equal to, this is going to be negative 18. Then I'm going to divide everything by negative 2. And this is where that little alarm bell should be going off in your head. We're dividing everything in an inequality by a negative number. So that's going to cause all of my inequalities to flip in the opposite direction. Negative 14 divided by negative 2 is 7x, and negative 18 divided by negative 2 is 9. So I end up with 7 is less than x, and x is less than or equal to 9. So let's make sure I can squeeze in all of my numbers here. At 7, I want an open circle because it's just less than. At 9, I want a closed circle because I want to include the 9. And then I want numbers that would make this true. What are some numbers that 7 is less than my number, but my number is less than or equal to 9? Well, that's going to be all these numbers here around 8. So when you're solving an compound inequality with and, you're going to shade in between those two circles. Solve it the same way, plug everything in like you normally would. But in this case, we only want things that work for both parts of the inequality, so we're going to shade in between. Next one is called an an or inequality. Best way to do it is think of it as two separate inequalities. You're just going to happen to graph both of them on the same number line when you're done. So start with this one here. 3x plus 1 is less than 4. So I'm going to solve this one. It's independent of my other one. I'm going to divide by 3. X is less than 3. Do the same thing here. I'm going to add 5 to both sides. 2x is greater than 12 divided by 2. X is greater than 6. So I need to fit a 3 and a 6 on here. So let's do 3, 4, 5, 6. And then we keep going in both directions. And here we're basically going to graph two separate inequalities. They're both just going to happen to be on the same line. So x is less than 3. So we're going to use an open circle at 3 and shaded numbers less than. So we're going to shade in the left-hand side. Over here, x is greater than 6. So again, we're going to use an open circle, but this time we're going to shade numbers that are greater than 6. So this is where it comes up with the description of an or inequality. So numbers are either less than 3 or greater than 6. Depending on which ones we choose would satisfy this inequality for us. Let's try another one here. Same idea. Solve each inequality separately. So I know that x is greater than 7, or I'm going to subtract 8 from both sides, or add a -8 if that helps. So x is less than or equal to -8. Remember, by adding or subtracting a negative, that doesn't flip my inequality, it stays the same. So now I need to graph it. I want x to be greater than 7 and x to be less than or equal to -8. So I'm going to have to do a little bit of cheating here just to get everything to fit on my number line. So I'm going to have to count by 2's and do a little estimating in between. But basically I want to graph both of these. X is greater than 7, so my 7 would be in here. So I'm going to use an open circle at 7, and I'm going to shade numbers that are greater than 7. Or x is less than or equal to -8. So at -8, I'm going to shade in my circle. I'm going to use a closed circle, but I want numbers that are less than or equal to 8. So basically it's saying numbers that are below -8 will work, or numbers that are greater than 7 will work. For at least one of the inequalities, nothing will work in between. So none of these numbers in between -8 and 7 are going to be solutions to our inequality. So an and, you're shading in between your two circles. An or is you're shading the two ends. There's nothing in the middle that will work, but the two ends of your number line will satisfy one or the other inequality. There you go.